These are the 2.2b notes. This is all about solving systems by substitution. So substitution is one of the other methods we're using in addition to elimination, which we did yesterday, and graphing the day before. So for substitution, in order to use substitution, we need to get a variable by itself. A variable, remember, is just another word for a letter. And so when we need to do substitution, we need to get a letter by itself. So that's either going to look like x equals something or y equals something. It really doesn't matter. Both will work. Let's look at our first example. Example number 1. Y equals 3x minus 13, and then 2x plus 2y equals negative 10. So notice here how we have this y equals. I'm going to box that. And I'm going to substitute this in. So think about a substitute teacher. If your teacher's not there today, your teacher is gone, and your substitute comes in to take the place. So you need to think about y. That's like me. I'm your teacher. But when I'm not here, a substitute comes in, 3x minus 13, and takes my place. So down here on the second equation, here is me. I'm going to leave, and the substitute is going to take my place. So it's going to look like this, 2x plus 2, and then I'm going to substitute the 3x minus 13 in where the y used to be. Again, we're substituting it in for the letter that it's equal to. And then finish it off with the equals negative 10. Now, once you get to this first step, you should only have x's. Or if you're substituting in the other direction, you should only have y's, but you should not have x's and y's anymore. All right, so then I'm going to distribute. I'll combine my like terms. 2x and 6x are on the same side. 8x. And then I'll continue to solve. I get an answer of x equals 2. Now, just like before on our substitution, that's only one part of the answer. We have to get the other part. So I'm going to substitute it back in. Let me erase some of this stuff over here for us. And I'm going to substitute it back into this top equation. That's going to be the easiest place to substitute it in. So it's going to substitute in for the x. And since the y is already by itself here, all I have to do is work on the right-hand side and simplify it. 3 times 2 is 6. And 6 minus 13 gets me negative 7. Remember, we write our final answer always as an ordered pair. X comes first, y comes second, to negative 7. All right, example number 2. This one's set up a little bit differently. You have x equals this time. And we're going to substitute it in that for that x. So the equation is going to look like this. 2. Substitute it in. 5y plus 9. Finish off the rest of the equation. So you're writing this exact equation, but you're substituting out that x. Then we distribute. You're going to get 10y plus 18 plus 3y equals 5. Combine your like terms, your y's. 10y plus 3y is 13y. And see if you can solve that equation. Subtract 18 Use your calculator if you need to. Y equals -1. All right, so once we have one of our answers, we can go back to one of our original equations and we can plug in our y. Again, the easiest place is going to be right there. X equals 5. Plug in the y, -1, plus 9. All right, take a moment, solve that out for x. You should be getting an answer of x equals 4. And then see if you can write your final answer as an ordered pair. 4, -1. Great job. All right, let's look at example 3. For example 3, I noticed something a little bit different here. I noticed that this equation is not exactly solved for y. So what I'm going to do is I'm going to get rid of the 2 in front by dividing out a 2 in each of these pieces. The 2's cancel, leaving me y equals. That's important. That's what I need. -4x divided by 2, -2x, and 2 divided by 2 gets me 1. Once I have that solved for y, I can go ahead and plug it in right here. See if you guys can write that equation with the -2x plus 1 plugged in for the y. It should look like this. Make sure you're plugging it in for the correct letter. If it's y equals, make sure you plug it in for the y. All right, now it's your turn to distribute. And see if you can simplify that problem all the way out to find your answer for x. Your last step, divide by 9. And you get an answer of x equals -1. Then once we have that answer, we're going to plug it back in. And you can actually plug it back into this equation. And go ahead and do that math and get your answer for y. -2 times -1 is 2, and then 2 plus 1 gets 3. And like always, make sure you write your answer as an ordered pair. X always comes first, y second. All right, one more example here. Your job is to set this up, and then this is kind of one of our special cases. So see if you can plug the y in, substitute it in, and see what you can get. So you should have done 4x minus 2, and then in parentheses, substitute out the y, substitute in the 2x plus 6. Distribute. And when we combine like terms, 4 and negative 4 actually cancel each other out. So what that leaves us with is negative 12 equals 5. And since I don't have any more variables, then I have to decide whether that statement is true or not. Is negative 12 equal to 5? No, it's not. So my answer, if you remember, just like when our two lines did not cross in our graphing problems, we write no solution. If the two had been equal, let's say you got an answer of 5 equals 5. Then you would say infinitely many solutions. Or you could just write out many solutions. Okay. So kind of two special cases there, similar to the ones that we did the graphing. All right, so that's it for today's notes. If you have any questions, you let me know. Send me an email or join me on Friday.